Hello there, welcome to Top Channel 101. So today I want to show you how to make rain using geometry nodes inside Blender. Yeah, so let's get right into it. So this is the setup I have. You can see I have, if I play back, you can see I have some rain particles and some splash or secondary particles here. And if you look at the render details here, these cones are just have a splash texture like that, and you can animate this. Let me just show you what controls you have over it. We can play with the start position. You can control the rain start position. So if I set this to 0, okay, can just make it start a single drop and then more drops, and then this increases like that, and then it ends. If I want more density in the rain, there is a rain density option here. If I want, because you can see right now the rain only lasts about 100 frames, and then it starts to fade in. You can use the rain offset to, let's scale this to maybe 1000. So this will make sure that the rain extends even further. If we want to extend it even further, you can do maybe let's try 2000. So it goes on for a little longer. But let's get into this and make the rain. So I'm just going to start a new blend file here, and I can start with a plane, go to geometry nodes, and go create a new setup here. I'm going to first distribute points. Let's add a distribute points on faces. This will just have these particles. We can increase the density. Now we can start even exposing some stuff. So I can control the density just here. Now the first thing I want to do is randomize the Z position of these particles. So I'm going to do a set position like this. I'll grab a noise texture, and then separate or combine so that I can offset the Z distance of this. The noise usually comes with an offset, so I'm going to subtract that with a math node so that everything is brought back to the center. So if I subtract 0.5, everything goes back to the center. We want this noise to be multiplied up, or to be scaled up. So this, I can use a multiply, and that gives me that. So this control here is going to be, if we go back to the original, it's going to be this. Yeah, it's going to be this rain offset. Just lets us scale the distance between each particles. So let's go back in here, and I can use that, expose that, and let me call it offset. Basically, that will give us the vertical distance. And now to animate this going down, all we need is another set position here with so we can basically animate the Z position like this, and with using the scene. So if we find time, thank you for subscribing, Dodon Ahmed. So if we get time, we can do a math node and combine XY, because we want to offset the Z position. We can just multiply the number of frames or the number of seconds by something, and then we should add that to the frame. Yeah, we need to multiply it by -1 so that the particles go down, and -1, so the particles go down as a result of gravity. And then to give us to control the speed, we can multiply another value here, so maybe 10, and that should give us the speed of the rain. I can expose this as speed as well, speed like that. So let me increase the density to something like 200, and spread this offset to about 200 as well. So we have actually not maybe to a scale of 100 like that. So if we animate this, you can see what we are getting. Now, if I rotate this, you can see I get the direction of the rain, some directional rain. Let me bring the timeline here. Okay. So you can see what we have. You can see what we have here. Now, one thing we see is that we need a point where the rain starts and a point where the rain ends. We want the rain to start exactly at the origin. So what I'm going to do is delete any points that are above the origin. So I'm going to do a delete geometry. And so our origin, let me see, can I show, is here. Basically the pivot point of this. Let me first clear the rotation. So we want to delete any points above that. Right now we are deleting everything. So we can get the position of each particle, and let's separate the different components and just compare the z position of each particle to a value. So I can do a math node here and compare the z value. So anything greater than this threshold should be deleted. So I can do this, and now you can see this, and the threshold can just be 0 because that is the pivot point of our rain. So now you can see we have that. We have control over the speed, so I can have this reduce the speed. And you can even scale this up, so you can have a more. You can double the density maybe, so ×2 to get more rain. Or reduce the offset, say by 50. Okay. I usually also like to see the boundaries of our rain, so I'm going to grab the original mesh and join it with the particles. So join using the join geometry, and then I'm going to grab this, and you can see what we have. But I don't want to see the face itself. So before I join it to the geometry, I'm going to convert it to a curve that will get rid of all the faces we have and just retain the edges. So mesh to curve, and that should give us that. So I can easily see my emitter. So now what else do we need? We need an end position. So we don't want the rain to go off forever like we are having it here. We want it to end somewhere at any position. We can use an empty or any object. So let me grab an empty like this, and I can use that to control the position where what part of the end position of our particles of our rain. I can just drag. Let me name this rain. This end position, position. Drag the empty in here. And in the same way we deleted the top particles, the particles above the starting point, we can delete any particles below the starting point, below the end point. So I can add another delete here, and from this I can just basically just get this setup and use the location of our empty of our end position, and basically compare that the z position of that with this, and get actually no, I need this position because we want the position of the particles compared to the z location of compared to the z location of the object. So I can do a separate z like this, and use this as the selection, and this should be, I think, less than. Oh, you need to make sure that you set this to relative, so that the position updates as you move this empty around. So like that, I can now easily control the end position of our rain using an empty like that. If you don't want to use an external object, you can just have this, expose this as endpoint, end rain, call this end rain. So we don't need an extra object in our scene. So for that, so let me get rid of that, but I've shown you how to add the object if you want. So now our rain, you can see, has an end position like that, which is amazing. Now let's create a raindrop. That should be very easy. We can just get this face, extrude, shade smooth, maybe other subdivisions apply, but this is too much geometry for what we want. So let's decimate this. Okay, so we have something like this, low geometry, low density polygon, and yeah, so we can use this. I'm going to call this drop, and here we can use instance on points, so basically replacing the points with the geometry we have. So like that, I'm going to apply the scale and rotation. So we have that. So you see what we have. I can scale these particles down, and I randomize the scale as well. So I'm going to use a random value here. Just connect that to the scale, and I just reduce the minimum scale like that. Another thing we could do is, if we want the raindrops to be longer, because yeah, just to have that control. If you want the raindrops to be thinner or longer, we can do combine XY, combine XY, Z like this, and I just have this set to 1, and and then do a vector scale, vector math, get this, use the scale option, and we should be somewhere here, scale, yeah, scale option, connect this randomness there, and then this to that, so that basically we still have the same setup. So now I can make this thinner, or just make the rain longer like that, the raindrops longer like that, and we have that. You can rotate this, maybe make it even wider in edit mode. That will also increase the density. You can increase the end rain. If we have an obstacle like this, let me turn on random colors, an obstacle like this that we want the rain to collide with, we can have a collider collection. So I'm going to have this in a collider collection, or colliders collection, hit OK, and I can even add maybe a few other objects in that collection, maybe a cube, maybe a Suzanne head right there in the same collider collection. Come here, and yeah, before we turn the instances into droplets, we can also delete any particles that collide with any of these using proximity, using the proximity node. So let's first grab the collection and set this to relative. And setting this to relative will just make sure that all the particles, all the objects in this collection retain the same position. So if I do a set position, you can see that all the objects are in the same position. Just adding this to show you that when you use original, you will lose that. So you need to make sure that you have set everything to relative, and so the positions are set. Now we want to use proximity, geometry proximity, and the collection is going to be our target. And so we want to delete any particles. Let's go back here, previewing these particles here. So any particles that are too close to these objects, let me first actually move them closer. We can delete them. So I can do a compare using a math node, and I do a compare the distance with a threshold. So I would do this here. Let me make sure that we're previewing the right. So we are getting an error here because we need to convert to realize this geometry. So realize geometry, and now you can see any particles that are too close, that are close to this, get removed. As you can see, yeah, when particles are close to these, they just basically get removed completely. But yeah, I think that's it. The only issue is that when they go beyond that threshold, they will be brought back in the simulation, which doesn't really matter that much since we are dealing with rain. It's too random for anyone to tell that is happening, so I'm not bothered by that. And now we can, so because we'll be always seeing this above, you can see the threshold. You can control the distance between the particles by playing with this threshold here. There may be this as well, so I'm not worried about the particles under here because they won't be seen, and you can just use the end position to get rid of some of those at least. And now we have that. You can add reactive particles to this that kind of bounce off the, just to show that there is a reaction or splashes of other particles after the raindrops hit, by just using the collider collection here and distributing particles on faces, points on faces. So we have this here. If we look at this, you can see we can add, let me add a Suzanne head back in this collection. So anything in this collection will have some particles on it. So if I bring this up, one thing to note, if you're doing this, you need to make sure that the scale of the object is applied. Otherwise, some particles are going to be larger. Now we can replace any of these particles with a splash particle that you might have. I created this splash particle already, so I'm not going to go through the process. It's just a cone with a splash material like this. You can obviously make a better one than I did. But actually, I think I can even make this better. Let me just add a seam and unwrap this. Then I should, if I straighten, or let's try cylinder projection. That should give us a better projection. Yeah, you can try and get a better splash effect than mine, but I'm going to use this. I'm just going to paste it here. Replace it with where is my rain? Just drag the splash in here, and I just distribute or instance it on the particles. Scale it down. So now you have, if we play back, nothing really happens, but we can play with if we add a random value, let me bring this here, random value, and change the type to Boolean, connect this to pick instance or selection, any will do. You can play with the seed, and that will just have this the seed animated, and that should give you some sort of animation for the splashes. If I look at the rendered thing, you can see the splashes happening. Let me give this a darker material. You can see the splash again. You just have to animate that. Maybe we can animate the seed using a scene time as well. So something like that. You can basically have some, and maybe randomize the scale as well. this to slow down a bit, we can try adding a math node here. Let me see if that and say if you multiply this or divide the time, you can slow down how frequently the splashes are played or are changed. Now, if we combine this with everything else, you can play with different parameters to make yours more convincing. But yeah, if you look at mine here, thank you for watching. I'll see you in the next video. And if you want the project files, I will be posting that on my Patreon page. So yeah, thanks for watching. I'll see you again.